Okay, a couple of different things you could do, and certainly a test for divergence, just look at the limit as n goes to infinity of this thing over here, which is the nth root of 2 minus 1. All right? Now, looking at that, let's just be careful about that, see what happens over here. So it's going to be a limit, n goes to infinity, and you're going to get 2 to the 1 over n minus 1. And let's take a look at that. As n goes to infinity, you're going to get 2 to the 0, which is 1, and 1 minus 1 is 0. So I'm going to say this really didn't help me at all. So I'm going to pretend I didn't do that. Let's erase that over here. All right? So test for divergence really doesn't help me out too much. And, I'm looking at it still, and I'm wondering, what could I do? I could do a comparison. So looking at it, I'm wondering what comparison to make, and I don't have many. And one thing I'd like to do is just talk about what an is. I'll write it down for you. And this is going to be, let's see, the nth root of 2. So I'm going to put 2 to the 1 over n minus 1. And I need a comparison for it. And the comparison I'm going to put down is, before I do that, I want to make sure that this is a positive term series. And as n gets large, it does go towards 1. But from the top of it, so it's going to be a positive term series. And let me put down Bn. I'm going to try 1 over n. And this is a divergent. If I write this one over here, so if I start n equals 1 to infinity of 1 over n, this is divergent, a harmonic series. So I'm going to use this limit comparison test, all right? But you could also do a comparison test over here. But let's do the limit comparison test. What do you get over here? Let's take a look. Limit as n goes to infinity. I'm going to put the an down. That's 2, 1 over n minus 1. And the bottom, what do you get? You just get 1 over n. All right? What does that limit give us? Let's take a look at it. And I gotta be careful over here. As n goes to infinity, the top goes towards 0, and the bottom goes towards 0. All right, so I think I need to go to L'Hopital's rule, because I really had seen through this. All right, so let me write a little bit differently. I'm gonna write it as limit. I'm gonna use a different letter. I'm gonna say a goes to 0, and this would be 2 to the a minus 1, and this would be a. I'm still getting that L'Hopital's, right? So let's put this down, and I got to do the derivative, right? L'Hopital's rule. I'm going to write it, write it with x's now. My eraser out, because it makes more sense because we're talking about continuous functions, right? So let me get my eraser out. Erase this whole business over here and write it so I can do the limit. So limit x goes to 0, 2 to the x minus 1 over x. So I'm going to use L'Hopital's rule. Limit x goes to 0. By the way, the limit at top is x goes to 0 will be 1 minus 1, which is 0, and bottom is 0. So I can use L'Hopital's rule. Derivative of the bottom is 1. That's pretty easy. I want to remind you, though, to get the derivative of the top. Let me just remind you, because it's easy to forget. So I'll take the natural log of both sides, ln y. That'll be x ln 2. And let's take a look at that derivative. You get 1 over y dy dx. And that would just be ln 2. And so dy dx would equal y times ln 2. So dy dx, well, what's y? It's 2 to the x, and then you get ln 2. So I got the derivative. Let's write that down. It's going to be 2 to the x, ln 2, and then minus the derivative of 1, which is 0. And what's that limit going to be? Let's take a look at it. And you get what? As x goes to 0, you could just get ln 2. That's not bad. Now, ln 2, I hope you realize, is greater than 0. All right, so I got a convergent series. This is convergent now. I'm sorry, I misspoke. This is divergent. This is indicating that this series is also divergent. And we're done. Thank you.